welcome to the deep dive.
Think about your daily workflow for a second.
Oh yeah, we've all been there.
Right, you're sitting at your workstation, you need to pull down a new developer tool or maybe a local AI assistant, and you just want to get it running.
You're in the zone. You don't want to stop.
Exactly. So you hit your search engine, you find the official-looking documentation, and you scan the page for that single line of installation code. You highlight it, hit copy, bring up your terminal, paste it in, and hit enter.
Boom. Done.
For anyone who spends time configuring environments or testing new software, this sequence is, well, it's pure muscle memory.
Oh, absolutely. We barely even look at the string of text anymore.
We just want the friction out of the way so we can get to the actual work. But that specific reflex, that split-second action of copying and pasting a command directly into your terminal is currently being weaponized.
And in a way that is incredibly difficult to spot.
Which is terrifying. Okay, let's unpack this. The mission for our deep dive today is to break down the anatomy of a massive new social engineering campaign. Right, a campaign that preys specifically on that desire for a quick, frictionless setup.
Our main source for this is a really comprehensive report. It was published on March 6, 2026 by Bill Toulis over at Bleeping Computer.
And he's detailing some highly sophisticated research from Push Security. They're a browser threat detection company.
And they've been tracking this new technique they call InstallFix.
Yeah.
And I have to say, the architecture of this attack is genuinely brilliant in its simplicity.
It really is. It's a profound vulnerability hiding right inside our standard operating procedures. The mechanics of how we install software have prioritized speed over verification for years now.
And threat actors are exploiting that exact cultural shift.
Exactly. And we're not just talking about obscure software here,
Yeah.
right? The campaign Push Security analyzed was actively targeting users trying to install Anthropic's Claude Code.
Which is huge. That's a wildly popular command line interface coding assistant.
It is. And that target selection is key to understanding the stakes here. Historically, if you were executing command line instructions, you were likely a sysadmin, a DevOps engineer, or, a seasoned developer.
You had a certain baseline of security training.
Right. But the democratization of AI has completely fractured that boundary. Today, you've got project managers, technical writers, everyday learners spinning up command line tools like Claude Code just to automate their workflows.
So the attack surface has expanded massively.
Massively. It includes a huge demographic of professionals who might not instinctively scrutinize a terminal command. That makes the blast radius of this InstallFix technique significantly larger than traditional developer-focused attacks.
And the research highlights how this attack leverages a very specific modern habit. The reliance on curl to bash commands or similar piping methods.
Which we see everywhere in official documentation now.
Everywhere. It's a single command that tells your machine to fetch a script from a remote URL and pipe it directly into an execution shell.
Developers love it because it bypasses the multi-step process. You don't have to download a package, verify hashes, change permissions, run an installer.
It's just one line of code and boom, your environment is configured.
But as the researchers point out, people are pulling these scripts from the web and executing them without running any kind of static analysis.
Or even just reading the raw file first.
No one reads it. That ingrained habit of blind trust is the engine driving this entire campaign. InstallFix is essentially a next-generation evolution of the older click-fix technique.
But without the heavy-handed scare tactics, right?
Exactly. Older social engineering attacks relied on creating panic, flashing banners claiming your system was infected, prompting you to download an urgent fix.
InstallFix goes in the completely opposite direction.
Yes. It relies on passive deception. Push Security found that the attackers are building perfect pixel-for-pixel clones of the legitimate software documentation pages.
Here's where it gets really interesting. You look at the visual evidence provided in the Bleeping Computer report. They compare the genuine Anthropic documentation with the malicious clone, and there is zero visual delta.
None. The threat actors scraped the CSS, the typography, the branding layout, everything.
Everything. But the genius is in the hyperlink routing. If you land on the malicious fake page, every single peripheral link in the navigation menu actually redirects you back to the legitimate Anthropic domain.
The privacy policy, the API reference, the About Us section.
They all route to the real safe infrastructure. The only elements on the entire page that have been altered are the specific copy-paste installation commands provided for macOS and Windows.
Which is just a masterclass in psychological manipulation. The attackers understand perfectly how we audit our digital environment.
How do you mean?
Well, when a technical user lands on a new documentation page, they might do a quick sanity check. They hover over a few links, maybe click the sidebar to see if the navigation works.
Just a quick vibe check to see if the site is real.
Right. And because all of those peripheral elements behave perfectly and point to a high reputation domain, the user's threat radar completely powers down.
The Bleeping Computer report notes that our current mental security model is heavily weighted toward trusting the domain and trusting the layout.
The attackers are constructing a perfectly safe house for you to walk around in, knowing that the only door you actually came to open is the one they booby-trapped.
That is such a great way to put it. But that brings up the obvious logistical problem. How are they driving traffic to these booby-trapped pages in the first place?
Because nobody's manually typing in a sketchy, misspelled URL to find Claude Code documentation.
Right. The Bleeping Computer report details that these clones are being aggressively pushed through malvertising campaigns on major networks, primarily Google Ads.
So a user searches for standard high-intent queries, things like Claude Code install or Claude Code CLI.
And the malicious infrastructure is sitting right there in the sponsored placement, sitting right above the organic, legitimate results.
The efficiency of that distribution model is staggering. Buying ad space for high-intent technical queries guarantees that the victims arriving at the clone site are already primed to copy and paste code.
They are already in execution mode.
Exactly. And the evidence Bleeping Computer uncovered is very specific. During their testing, the top sponsored search result for the query install Claude Code directed users to a Squarespace URL.
The exact domain was claude-code-cmd.squarespace.com,
And that link served up the flawless Anthropic clone.
which highlights a massive blind spot in automated security scanning. You might wonder why enterprise antivirus or endpoint detection and response tools aren't catching these malicious URLs the second they're indexed.
Well, it's because the threat actors have largely abandoned the practice of standing up their own sketchy infrastructure.
They aren't using bulletproof hosting jurisdictions that ignore takedown requests anymore.
Not at all. They're using the exact same enterprise-grade infrastructure that Fortune 500 companies use. What's fascinating here is the deliberate abuse of domain reputation.
Security scanners and ad network vetting algorithms often rely heavily on the historical reputation of the host, right?
Precisely. The infrastructure choices highlighted in the report, Cloudflare Pages, Squarespace, Tencent Edge One, these are massive, highly trusted platforms. They host millions of legitimate businesses.
So a security tool can't simply blanket block traffic to Squarespace or Cloudflare.
It would cause catastrophic business disruption. So by nesting their malicious clones within these high-reputation environments, the attackers are effectively laundering their threat footprint.
They're hiding in plain sight, wrapped in the credibility of the internet's most trusted platform.
And we are seeing this exact playbook replicate across different platforms and search ecosystems.
Yeah, the report notes that just a week prior to this Claude Code campaign, threat actors utilized the same InstallFix methodology to target a different tool called OpenClaw.
But instead of Squarespace and Google Ads, they hosted the fake OpenClaw installers inside GitHub repositories.
And then those malicious GitHub repositories were actively picked up and recommended by Bing's AI-enhanced search features.
So you have an AI search engine scraping a trusted developer platform like GitHub and confidently presenting the user with poisoned installation instructions.
It completely bypasses the traditional user vetting process because the AI is essentially endorsing the source.
The compounding trust issue there is deeply concerning. You have the inherent trust in the AI's aggregation combined with the inherent trust in GitHub as a safe repository for code.
When those layers of trust are chained together, the user's skepticism drops to zero.
They copy the command, they open their terminal, and they execute.
Which is the pivot point of the entire attack.
Yeah.
The moment that command hits the terminal and the enter key is pressed. Let's talk about the payload.
The payload that gets pulled down in this specific campaign is an information stealer known as Amatera.
For those tracking the evolution of malware as a service, Amatera is essentially a highly refined successor to the older ACR Stealer.
And the economics of this are entirely subscription-based. The people running the malvertising campaigns likely didn't write a single line of the malware itself.
They're just paying a monthly licensing fee to the Amatera developers.
Right, to access a fully managed, constantly updated data theft platform. The malware-as-a-service model has radically lowered the barrier to entry for executing these campaigns.
While simultaneously increasing the sophistication of the payload.
Exactly. Amatera is purpose-built for silent systemic extraction. According to the analysis in the Bleeping Computer report, once it executes, it immediately begins harvesting high-value assets.
It actively hunts for local cryptocurrency wallet files.
It scrapes the system for stored credentials. But the most critical function for the average professional is its focus on web browsers.
Amatera is designed to extract saved passwords, active cookies, and live session tokens from the browser's local storage.
The session token extraction is the true nightmare scenario here.
Because if an attacker gets your active session tokens, they don't need your username.
They don't need your password.
They don't even need to bypass your two-factor authentication.
No, they simply inject that token into their own browser. And the service, whether it's your email provider, your corporate AWS dashboard, or your bank, it believes they are you.
It sees them as already authenticated and logged in.
And the Bleeping Computer report explicitly notes that Amatera is engineered to perform all of this extraction while actively evading detection by standard security tools.
The evasion techniques are baked into the initial execution chain, right?
Yes, and the threat actors have tailored those techniques specifically for the target's operating system.
Because the commands you copy from the fake Squarespace site are dynamically served based on whether you're running macOS or Windows. Let's look at the macOS execution chain first.
The malicious string provided for Mac users relies heavily on base64 encoding. Instead of a clear human-readable URL pointing to the malware, the command contains a massive block of encoded text.
Now, base64 isn't encryption. Anyone can decode it.
Right. But its purpose here is to bypass basic static analysis and string matching security scanners that are looking for known malicious URLs.
So when you paste that block into the macOS terminal, the command tells your system to decode the string on the fly and execute the resulting instructions.
And those decoded instructions are what actually initiate the network connection. The terminal quietly reaches out to an attacker-controlled domain.
The Bleeping Computer report identified one specific node as reconsult.com, though they noted that particular infrastructure has since been taken offline.
Right, but it reaches out and it downloads a malicious binary directly into a hidden directory on the Mac.
It then changes the file permissions to make it executable and runs the Amatera payload in the background.
All without throwing a single graphical prompt to the user.
Completely silent. Now, the Windows vector takes a completely different approach. It relies on what the industry calls living off the land techniques.
Yes, the report details how the fake PowerShell or command prompt instructions abuse native, legitimate Windows utilities to orchestrate the infection.
Specifically, the command invokes emshta.exe. For context, emshta.exe is a built-in Microsoft utility designed to execute HTML applications.
It's a legacy component, but it is deeply integrated into the Windows operating system. The strategic value of mishta.exe for an attacker cannot be overstated.
Because it's a digitally signed official Microsoft binary.
Exactly. Almost every endpoint detection and response platform inherently trusts it. When the pasted command tells mishta.exe to reach out to the internet and parse a remote script, the security software generally allows the network connection.
And it just views it as legitimate system behavior.
The attacker is essentially using the operating system's own trusted tools as a proxy to fetch the malware.
And the execution chain on Windows doesn't stop there. The report notes that after mishta.exe pulls the initial script, it triggers another native process,
conhost.exe.
the console window host. This is the process that normally provides the interface for command line applications in Windows.
By hijacking conhost.exe, the attackers create a stable, trusted execution environment for the final Amatera payload to run its extraction routines.
They're chaining together these native system binaries to create a smokescreen, making the data exfiltration look like routine, authorized background activity.
It is a phenomenal example of defensive evasion. By the time any anomalous behavior might be flagged by heuristic monitoring, the session tokens and crypto wallets have already been packaged
And transmitted back to the attacker's command and control server.
The speed of the execution chain from the moment the user hits enter in the terminal is measured in milliseconds.
So what does this all mean for you? It's easy to look at the mechanics of base64 decoding and emshta.exe proxy execution and think this is solely an IT problem.
But the core vulnerability here is human behavior.
Exactly. The democratization of command line tools means that setting up software via the terminal is no longer a niche activity. If you are downloading a local language model, configuring a new development environment, or just following a tutorial you found on YouTube,
You are navigating the exact terrain where these traps are being laid.
the convenience of a one-line setup command is universally appealing. And that appeal is exactly what the attackers are monetizing.
Altering that behavior requires a conscious shift in how we interact with documentation. The Bleeping Computer report outlines specific mitigation strategies that are incredibly practical.
The foundational rule is absolute strictness regarding the source of your installation instructions.
You must navigate directly to the official project repository or the verified corporate domain. You cannot rely on a search engine to hand you the correct domain on a silver platter.
Because the integrity of those search results is actively being compromised.
Which leads directly to the second mitigation outlined in the research: the active avoidance of promoted search results.
We have to treat the sponsored placement on Google, Bing, or any other engine as untrusted territory when searching for software or technical documentation.
We have clear evidence that threat actors are outbidding legitimate companies to place perfectly cloned malicious infrastructure in that top slot.
Scrolling past the ads to find the organic search results is no longer just about avoiding marketing. It is a critical security control.
And the third strategy recommended in the report is a return to a very traditional web habit:
Aggressive bookmarking.
aggressive bookmarking. If you are a developer, a project manager, or an AI enthusiast who frequently needs to pull down tools, access documentation, or re-verify installation commands,
You should be bookmarking the verified, legitimate portals, relying on a fresh search query every time you need to reference the Claude Code documentation or an OpenClaw repository introduces unnecessary risk.
if we connect this to the bigger picture, it becomes painfully obvious that our desire for workflow velocity has completely outpaced our security fundamentals.
The tech industry built a culture around the speed of copy-pasting code.
And the criminal ecosystem has simply built a toll booth on that exact workflow.
To bring all these threads together for you, the deep dive today highlighted how the simple act of installing software has been fundamentally weaponized.
A standard query for a popular AI tool like Claude Code can easily surface a sponsored ad, driving you to a flawless clone hosted on a high-reputation platform like Squarespace.
That clone page leverages the InstallFix technique, exploiting our muscle memory to trick us into copying a malicious command.
And depending on your operating system, that command uses base64 obfuscation on a Mac, or native trusted utilities like mishta.x on Windows to quietly pull down the Amatera Stealer.
Operating on a malware-as-a-service model, Amatera then systematically strips your machine of crypto wallets, credentials, and most critically, the browser session tokens.
The tokens that allow attackers to bypass your two-factor authentication entirely. It is a masterclass in exploiting trust at every single layer of the digital experience. This raises an important question, and it's one that challenges the very foundation of how we navigate the internet today. If AI search aggregators and heavily vetted multi-billion-dollar ad networks are actively serving us poisoned results,
And if that poison is being hosted on the exact same enterprise infrastructure we use to run the legitimate web,
how long until the concept of a safe search result is completely obsolete? As the lines between legitimate infrastructure and malicious payload delivery continue to blur, we have to ask ourselves, should we start treating every single line of code we copy from a browser, no matter how pristine the documentation looks, like a loaded weapon?
it fundamentally redefines the concept of zero trust, moving it from a network architecture principle to a personal browsing habit. Thank you for joining us on this deep dive. Stay curious, stay vigilant, and please take that extra second to read the command before you hit enter.